Welcome back. So let's now discuss some of the drawbacks for the PCA. First, you need to know that PCA assumes that the variables are linearly correlated. So if there is any non-linear correlations between the features, then the PCA will not be efficient, right? For example, let's take a look at this graph here or plot here. As you can see, there is a clear relationship or a clear correlation between x and y, or x1 and x2, right? We have this circle, okay? But this relation or this pattern is a non-linear pattern, right? So PCA works by linear correlations. So if we have any non-linear correlations, then the PCA will not find these correlations, and so the PCA will fail, okay? The second thing you need to know is that PCA performs lossy compression. So we will see this when we implement the PCA ourselves. You will see that some information will be lost, right? So here, if we have non-orthogonal patterns, then we have information that will be lost, right? So we will discard the insignificant components. For example, we will discard this component and we will just use this component to represent the full data, right? And using this way, any information here will be here, any information here will be here, and so on. So we have some information loss. Also, you need to know that scaling of variables can yield different results. Hence, scaling that you use should be documented. So any scaling you do should be clear and documented in order to know if this is actually correct or not. So scaling shouldn't be adjusted to match prior knowledge of the data, because our machine learning algorithms doesn't really assume anything about the data, right? We need to scale to have the scalar, and we don't really want to adjust the scalar to match our knowledge or previous knowledge of the data, okay? And the final thing you need to know about the PCA drawbacks is that since each single component is a linear combination of the original features, then when we visualize the new components or visualize the new features, sometimes they are not easy to interpret or relate to the original features. So let's say we have 10 features and we use the principal components and we got the first two principles or first two components, and we visualize these two components. You cannot really see or interpret this graph, right? Because we have two components and originally we had 10 components, and for each component it's a linear combination of all the original components. So the first component is a linear combination, the second component is also a linear combination of all the components. So visualizing it, it's okay, but trying to interpret what this means in terms of the original features cannot be very easy, okay? So these are the drawbacks of the PCA you need to know, and in the next lesson we will see the PCA algorithm steps. So we will see all the mathematics, we will discuss the pseudocode, and we will even see a video in order to understand the eigenvalues and eigenfaces and other concepts related to the PCA algorithm, right? So let's go to the next lesson.